Hello everybody, welcome to 8.2, solving systems of equations algebraically. So in 8.1 we did it graphically. I did a little bit of algebraic solution there as well, but let's recap what we learned from grade 10 on solving systems of equations. So you'll probably remember that there's two methods. The first one is when we have substitution. By using substitution, we transform a system of two linear equations into a single equation in one variable. So usually and especially the case with quadratics, when we deal with quadratics, we'll put these in y equals. It didn't matter when we did them linear, when we had y and x, but now that we have the x squared, it's a little different. So I recommend everything in y equals. And then what we do is we set them equal to one another and then we solve. So first one here, both these are equal to y, so we set them equal to one another and then we solve. Very simple. Next one, these aren't really set up too well for what we're going to do with substitution. These are more of an elimination. So this is what we would use for elimination. Just getting you to look at examples of, when is a good time to use substitution. And you can always use either one. But something like this first example here, where we have x squared minus 16x equal to y, and y is equal to 2x minus 1, we simply set them equal to one another. Right? Pretty straightforward. Elimination. By using elimination, we add or subtract the two equations in linear systems, produces equivalent linear systems. We can use this property to solve a linear system by eliminating one variable and adding or subtracting equations. So, again, remember that we have to get rid of the linear. So what I recommend is when you're doing these is that you want to eliminate the y variable, and that'll give you the x squared and the x, and then you have a quadratic, and then you can solve. So I think that's important that you remember that. So you want to get rid of that y variable here, because if you got rid of the x using elimination, then you would still have an equation with two unknowns, x and y, right? Get rid of the x variable, you have the x squared and the x squared. So the best thing to do here, in my opinion, is to get rid of the y variables using elimination. So in this case, you just add these together. Negative y plus y will be gone, right? And then this one here, this more will be better for substitution. So take the y and put the second equation into the first one here, y in terms of x, right? So I think that's important. So I'll do a few examples. So it says example, solve each of the following systems algebraically and verify your solution. So this left column is question 1, and this right column is question 2. So on the first one, I've rearranged equation 1 to set it equal to y. I got y equals negative 3x minus 9. Then I've substituted that into equation 2. So everywhere I see y, I put negative 3x minus 9. When I do that, I get 4x squared minus x minus 3x minus 9. The minus x minus 3x comes together and gives you 4x. I want to set one side equal to 0. So in this case, the easiest thing to do would be set the right-hand side equal to 0. So I add 9 to both sides. Negative 9 plus 9 is eliminated. It gives you 0 here. You don't see it, but there's a 0. If you wish, you could have the minus 9 plus 9, right? You see here, but obviously that's going to be 0, so it's gone. And then this gives us a quadratic. We factor out to 4x, leaving us x minus 1. So we have the first term. The first factor is equal to 0, so it's 4x equals 0, which means x is equal to 0. And the second one we have is x minus 1 equals 0, the second factor, which means that x is equal to 1. So there's your two x values. To satisfy this, we substitute them into equation 1 to find the intersection points. You could do either one. I did it the easier of the two. Substitute it in, I get 0 times negative 3 is minus 9. Negative 9 is 0 and negative 9. Do the same thing with the value of 1. Put a 1 in and we get negative 12. And those are your two intersection points between the linear and the quadratic here. We have a linear line and a quadratic line. Right? Quadratic curve. Quadratic function. Quadratic equation, I guess. So to verify, you can do it algebraically. Substitute both into equation 2. Don't put it back in equation 1. You already know what that is. So I just put them in the original equation 2. So 4x squared minus x minus y is equal to -9, plug it in, there we go, -9 is -9, check, put our 1 in, 1 squared is 1 times 4, 4 minus 1 is 3, 3 subtract 12 is -9, -9. And you can also verify using the graphic calculator as well. It's another verification. Putting the two equations in, but the key would be to put them both in y equals first. So take the 3x, so negative 3x, you have to take the 4x squared and negative x over here, right? Subtracting that respectively. And example 2 has done the same thing. Again, substitution. This is already y equals 4, so we just plug this into the first equation, right? So we're going to substitute equation 2 into equation. This should be equation 1, right? And so everywhere we see y, so there's the first equation, and then I replace y with 4x. Add the 2x and the 4x, get 6x. Subtract the 6x from both sides. I get 0 equals x squared minus 6x plus 5. Once you have one side equal to 0, then you can now factor. We factor when we get x minus 5, x minus 1. Set both factors equal to 0, and therefore our x values are 5 and 1. Substitute both values into either equation. Obviously, the second equation is easier to substitute them back into. So it's 4 times 5 is 20, and 4 times 1 is 4. So the two solutions are the coordinates 5 and 20, and 1 and 4. And to verify them, I'll plug them back into the original first equation. I wouldn't sub them back in here, obviously, you know that's true. So I'd sub them into the other equation that you didn't use to get your points. Makes sense. So we put 5 in for x, and 20 in for y, so 2 times 5 is 10, 10 plus 1 is 30, x squared, so 5 squared is 25, plus 5 is 30, both sides are equal, therefore it's good. Do the same thing with point 4, so I put 1 in for x, 4 in for y, I get 2 times 1 is 2, plus 4 is 6, 1 squared is 1, 1 plus 5 is 6, verify that both sides are equal to 6. So there's substitution. Next one we have example 3, and we're on page 15. This is use elimination. You'll notice that they're not set up for substitution or elimination, but you'll notice they're both at minus y. So if we were to subtract these, right, if you take negative y and subtract negative y, that's negative y plus y, which would eliminate the y's. So that's what I've done here. It's already set up for elimination. Remember, put your x squareds together, your x's and your y's, and then your constants. That could be on the left-hand side is equal to 0, right-hand side doesn't make any difference. So I'm going to subtract equation 2 from equation 1 using elimination in step 1. So it's 6x squared minus 4x squared, 2x squared, negative x minus a negative 4 would actually be negative x plus 4x, which would be 3x. Negative y, subtract that negative y is actually negative y plus y, which is 0. That's why there's a gap here. And then we have negative 1 subtract negative 6, which is negative 1 plus 6, which is 5. And then that's the first step. Second step is we set that equal to 0 and use decomposition of factor. So I subtracted the 5 from both sides and I got my equation. You could have done that on this step. It doesn't make a difference. And then I use decomposition. So two numbers multiplied together give me negative 10, added together give me 3. Would have been actually 5 and negative 2. So I've decomposed or broken down the 3x into negative 2x plus 5x. So I use the first two factors, factor the 2x from both, and get x minus 1. And I do the same thing with the last two factors, the third and fourth term. And I broke them up, or not factors, sorry, terms. You get the other factor. The factor out of 5, the GCF from both of these, I get 5 bracket x minus 1. Again, both of these have to have the same factor. And the GCF out of both becomes the first factor or second. It doesn't matter the order. So we have 2x plus 5 and x minus 1. Two factors equal to 0. Set both factors equal to 0. Solve. And the first one you get x equal to negative 5 over 2. And the second is x minus 1. This here part here. This is the elimination. This is the only new. Step 2 we know how to do. We know how to factor these, right? Decomposition. We factor this many a time. We did in grade 10, did in grade 11, and we're doing it again. We did in chapter 4, like it doesn't go away, right? Now to get the corresponding y values, so you're going to substitute your x values into equation 1 or 2 to solve for your y values. So I've done the first equation, I put x equal to 1 in, I've gotten a 6, then I've done the same thing, and I've solved, you can put -2.5. I'm okay with that because it's terminating, but if it was a non-terminating, like 1/3, leave it as a fraction. You could leave this as a decimal if you wish, and you would still get to 41. So it's your solution is this, and I'm okay with -2.5 and 41. So either one's fine, right? Same here, or it could have been -2. So that's acceptable as well, which is fine. Okay. And either way is good. Verified into the original or the second one, it doesn't matter. I put it in the first equation, you can put it in the second one, it wouldn't make a difference. I think in the one on the line, I did it in the second equation, which I probably should have, but it doesn't make a difference. That's verifying. Okay, there you go. So there's your two solutions right here. And there's your verification, the last step for that is verify. And then let's do an application question. And number 16, another one of this small number to large number. So it says determine two integers such that the sum of the smaller number and twice the larger number is 46. So the sum of the larger number, the sum of the smaller number, so I said x is smaller, plus twice the larger number, 2 times y is 46. And then I said equal to y. So I subtract the x from both sides, divide both sides by 2. I got -1/2 x plus 3. Then I got a quadratic in the second statement. It says also this when the square of the smaller number, so the smaller number squared, is decreased by 3 times the larger number. So subtract 3 times the larger number, y is equal to 93. Just said the same thing. Set them both equal to y. Then I set them both equal to one another. Could have done elimination here with the y's. It's up to you. It still work out. So I set them equal to one another. I set it equal to 0, so I add the 1/2 x to both sides. I subtract 23 from both sides. Then I want to get rid of this fraction, make your life easy, so I multiplied everything by the the greatest common factor, which would be 6. So I multiplied everything by 6. 0 times 6 is 6. 1/3 times 6 is 2. 1/2 times 6 is 3. And -54 times 6 is 324. I figured out that two numbers multiplied together to give me 648, so or -648. So it'd be this, it would be elimination. Again, at this point in time, you could use your graphic calculator to get the x values. -13.12. The algebra part is what I'm looking for, is the substitution or elimination. Once you get to the quadratic, it's whatever. Use any method, but if it says algebraically, technically you would have to do it. Here it didn't, so you could have really done it any way you want. You could have done this graphing, but I did it using my knowledge of factoring by decomposition. Alright, so the numbers were 12 and -13.5. Obviously -13.5 isn't an integer, so therefore this value is eliminated. It's no good, right? You can't use it because it won't work. And to get your y value, what we do is we take this x value and plug it into either equation. I'll do the first one here. So I'll take the first equation. So when you put in the first equation, you substitute the 12 in for x, you get -6 plus 7 or plus 23, which would equal 17. And then your point is 12 and 17. Okay. And the last one, we'll do in the next video. I don't want to rush it through, so I'll make you something. So we'll see you again in the next video, and we'll finish off the section.